All right, welcome back to Characteristics of Polynomial Graphs Part 2. All right, so we have to put it in standard form first. All right, so we're going to look at our biggest exponent. So my biggest exponent is a 5. So the 4x to the fifth term comes first. And then it goes in descending order. Exponent of 4 comes next. Exponent of a 3 comes next. I don't have an x to the second. I have a 2x, and I have a minus 1. All right, so now it's in standard form. The leading coefficient and the biggest exponent basically tell you most things you need to know. The degree is a fifth degree polynomial. Your leading coefficient is the 4, and your constant is -1. Remember that that is your y-intercept. This first term right here tells you everything you need to know. That determines your shape. So if I come up here, the leading coefficient is a positive number. Okay, so it's one of these two. And my biggest exponent is an odd number. All right, so it's going to look something like this. So I'm expecting it to go down to the left and up to the right and have some turns in the middle. So I would describe this as down and up. That 5 means you have at most 5 zeros. All right, so it goes down, and let's see, that -1 means that I have a y-intercept right there. All right, at most 5 zeros. 1, 2, 3, 4, 5. Doesn't necessarily look like that, but for introductory purposes, this could be reasonable. So your biggest exponent means you have at most that number of zeros or x-intercepts, and the constant tells you your y-intercept right there. All right, let's fill in the chart. As x goes to infinity, that means what's your graph doing to the far right? It is going up to positive infinity. And as x goes to negative infinity, means what's it doing to the far left? This one's going down to negative infinity. Number 2, try this one. I would hit the pause button and then come back and see if it matches it. All right, so in standard form, it goes biggest exponent first, -3x4 plus 6x to the third plus x plus 5. The leading coefficient and its exponent determines the shape. What is the degree? So the degree, this is a fourth degree polynomial. Technically, I think that's called a quartic. Yeah. The leading coefficient is -3, and your constant is 5. All right, so I know that I'm going to cross the graph about there. We'll call that 5. All right, what should my graph look like? All right, so your leading coefficient is a negative number, so it's this row, and your biggest exponent is an even number, so I'm expecting it to look like this. My graph is going to go down to the far left and down to the far right. So it's going to go down and down. Oops, sorry. There we go. All right, so maybe it looks like 1, 2, 3, 4. That degree tells you it has at most 4 x-intercepts. I didn't say exactly 4, I said at most. It could have fewer than that. Let's fill in the graph. As x goes to infinity, So that means on the far right, your graph is going down to negative infinity. As x goes to negative infinity, that means what's it doing to the far left? It is also going down to negative infinity. So that's how you would put it in standard form. Tell me the degree, the leading coefficient, the constant, and then maybe sketch a graph with its end behavior on it. All right, number 3. What is the degree of this? The degree always refers to your biggest exponent. This is a 7th degree polynomial. The leading coefficient is always the coefficient of your biggest exponent. Therefore, this is -4. End behavior. All right, so I have a negative paired with an odd. Can you remember what it looks like? Let's see, a negative paired with an odd. This is going to go up and down. And it has a y-intercept. It's going to go up and down. That right there tells me I have a y-intercept up here at 5. Up and down. It could look like this. This one does not have 7x intercept, so there are probably a couple of imaginary ones. We'll talk about that later. What is the constant? The constant is 5, and I sketched it. Number 4 is already in standard form. The first term tells you everything you need to know about it. Degree is code for exponent. This is a 14th degree polynomial. We have a leading coefficient of 2. What is its end behavior? All right, so do you remember? The leading coefficient's a positive number, and your biggest exponent is even. I can tell you that that is up and up, because that anytime that it's an even number, I think of a parabola. So I know it's going to look something like that, but with a lot of twists and turns in the middle. The constant. So if there's nothing there, that means you could add a 0, and that doesn't change anything. So I have a constant of 0, so that means that it's going to cross at the origin. And let's sketch this. All right, so I go through the origin. Theoretically, that could cross the x-axis 14 times at most, and it goes up and up. Bunch of twists and turns in the middle. So I challenge you to take that and put it into Desmos and see exactly how many twists and turns that one has. But the most important thing is figuring out what is its end behavior. Memorizing these two things tells me that I know that it will go up to the far left and up to infinity to the far right. Let's give it a graph. Let's see if we can work our way backwards. So looking at a graph, describe its end behavior. So to the far left, it's going down to negative infinity, and to the far right, it's also going down to negative infinity. So for me, you could say down and down. On a test, you would probably say, as x goes to negative infinity, f of x is going to negative infinity. As x goes to positive infinity, f of x is also going to negative infinity. So when it goes down and down, that means your f of x are both going to negative infinity. Does this represent an even or an odd? So the one thing that you need to recognize is that when your graph ends up going the same way, this is a characteristic of an even degree polynomial. So it has too many twists and turns to be an x to the second. This is probably like an x to the fourth or something like that. So when the end behavior goes in the same direction, that is characteristic of even. State the number of zeros. Zeros mean x-intercepts. So it has 1, 2 x-intercepts. Therefore, it has 2 real zeros. Number 6. All right, so when I look at the graph, it's going up to infinity to the far left and down to infinity to the far right. So as x goes to negative infinity, f of x goes to infinity. And as x goes to positive infinity, f of x is going to negative infinity. When your graph goes in opposite directions, this is characteristic of an odd degree polynomial. So this is an odd degree polynomial. How many zeros does it have? 1, 2, 3, 4, 5 zeros. If this has 5 zeros, this is likely a 5th degree polynomial. And on this one, they're going in opposite directions. So this is going up to the far left and down to negative infinity to the far right. Going in opposite directions is characteristic of an odd degree polynomial. It has 1, 2, 3 x-intercepts. Therefore, it has 3 real zeros. This is likely an x to the third. And then number 8, it is going down and down. So when your end behavior is going in the same direction, that is characteristic of an even degree polynomial. So this looks like a negative x squared to me because it's flipped and it's going down. How many real zeros does it have? It has 2 real zeros because it crosses the x-axis 2 times. So this is likely like a negative x squared. All right. Let me know if you have any questions later.